So let's welcome our next speaker, Velimir Iveljic. Velimir is a cloud platform architect specializing in cost-effective, scalable solutions for small and medium teams. And his topic will be building affordable cloud-native platforms for small teams with GitOps. Let's welcome him.
Hey, thank you. Already know my name. I'm Velimir. I'm a system architect and a DevOps lead at Open Research. It's a software consultancy based in Vienna. And today I would like to tell you about our experience of how we managed to pivot from using strong cloud deployments and infrastructure into building like a smaller platform for ourselves that we then started using also for our customers and consulting others how to do it. Before we begin, like, who here knows what a platform is? Just so, okay, at least some people. Basically, a platform in this context is an infrastructure platform where you are able to deploy your applications. And the concept is to enable your development teams to use this infrastructure with as less friction as possible, and also to offload some of the tasks that traditional operations team would be doing for them, like doing the deployment, scaling their application, managing the databases, et cetera, et cetera. Usually, the problem for many companies of smaller sizes is that this endeavor can be very costly because when we talk about platforms, usually how it's implemented, you have something like a portal where you can have a shopping cart and then you basically like choose what kind of application you want to deploy. Do you want database inside, storage, et cetera, et cetera. And to build this up with a nice UI, et cetera, costs a lot of time and money and effort. So a lot of companies are kind of deterred from going into this direction. And that's one of the things that I want to demystify today. Like, it can be done in a different way where you achieve most of the goodies that the platform brings with itself. Then the operational toil of it, like if it's a big platform, you now need a whole team just to manage this platform. There's a product team that's actually writing, I don't know, the application code for the user interface and the backend REST APIs and whatnot, what the users need to do. And second of all, like, mostly you would deploy this in a cloud solution, which is very costly and locks you into their environment. So even though you have this platform for your developers, this is all fine and dandy. Like, in the background, you're using heavy cloud infrastructure, like, I don't know, database instances, load balancers, networking, traffic. Everything's in the cloud, and it becomes very costly at some point. So small companies usually tend to not go there. So they're kind of left with this quasi-platform from AWS or Azure or Google Cloud. Like, you just use ECS instead of having your own Kubernetes, et cetera. That brings different costs on the table because this also, in the background, has all these components. It's just packaged differently and sold to you in a different way. Second big thing is, like, if you're having this ECS structure, which is then like not really a platform, like, your developers usually tend to not really want to deal with that, like deployments, et cetera. Then you mostly have some, like, in a small team, because you're a small company, have some Terraform scripts deployments, basically, that like have 7,000 resources to deploy a container or whatever. You need to attach it to a database. You need to do networking for this, create the load balancer, et cetera, et cetera, et cetera. So this is very infrastructure stuff that developers usually either don't have experience with or just don't want to deal with. So you have this churn, basically, where your operations team is basically now mostly doing deployment and maintenance of this stuff and talking to developers. Then there's like a huge feedback loop, like days go by until you agree. When do you do the deployments? Every deployment is like a scary thing. Are we going to break something? How are we going to roll this back? Because Terraform, you know, as good as it is, like sometimes you cannot go back when you change things. And yeah, this is just kind of drowning, like at least from the ops side, from infrastructure side, it's draining, it's making everybody miserable, and we kind of saw that it took away a lot of time that we could use to actually improve our infrastructure, bring down costs, and make everybody's life easier, and like make the deployments for developer faster and less error prone, give them more control about stuff, and generally streamline the process. So, yes, that happens. At some point during all of this experience, we decided like, okay, we have some experience in the team with building like on-premise infrastructure, because like a bunch of us have experience with this from previous work, etc. So we kind of like thought, okay, maybe if we host a Kubernetes cluster on our own, like how hard can it be? Everybody says that. But then we actually like put it on a paper and we tried it out. And the pivot was basically, we called it internally affordability pivot, like to commodity compute. So instead of using super expensive cloud infrastructure and building this elaborate platform that everybody is scared of, like you need, it's another product in your company at that point. So for small companies, again, this is not feasible. Let's just try to create something in the middle, you know. So we opted like, okay, let's check out some cloud hosting providers. We ended up using Hetzner Cloud because it's super cheap and you can configure mostly everything with APIs. So it's also easily automatable. And we designed something that looked like this. It's not a pretty picture, but we have like these 3 layers of infrastructure. I don't know why this is happening. Sorry, if it becomes worse, we'll fix it. We call it like the infra layer is basically your, it can either be bare metal or just like pure cloud compute, like virtual machines and the operating system on it. Then we have the control plane, which is running the Kubernetes. It's running your GitOps tool of choice. We opted up for Flux CD because it's the most flexible for a smaller team. I will show you later why. And like we didn't want to compromise on like the nicety of having like a super nice to use secret store that you can integrate either in your applications or like users have a user interface that can, you know, they can use it and like you can dump your secrets, they're encrypted, they're safe, etc., etc. And then the workload layer is just basically your applications and maybe an operator or two that automates things in the cluster. And then on the other side is this GitOps workflow. Basically, we write everything into Git as code. So infrastructure as a code is a big thing. And we have a couple of ways how we deploy these layers. So for the infrastructure layer, we just use Terraform to create the Hetzner cloud infrastructure. We first start by creating like a project. Of course, you do this manually. You get your keys in. And then you create the network, you start up your virtual machines, you create a load balancer, and then you boot up these virtual machines, your operating system that needs to run Kubernetes. So this was a big... Actually, we did as a first demo because that's the easiest to start with. But then you have this overhead, like now you have to maintain the Ubuntu image. You have to upgrade your cluster manually, like Kubernetes releases are quite often. Apt-get upgrade doesn't end up very well every time. So after investigating and doing some research, we ended up picking up Talos Linux. So it's, does anybody know about it? Oh, very nice. Talos Linux. So it's basically a Linux distribution that doesn't have any of the user space tools. It just boots up into the Kubernetes system. So like the init. What? Like CoreOS was. I don't know crawlers, but
Core OS.
how? Sorry.
Core OS. It was also just like the basic, and you do everything in containers.
Possibly, like I don't know about it, but possibly. Like so, this boots up into Kubernetes, and once it's up, like once you have your virtual machines up, you just execute like with Terraform. You can do this. This is how we did it. You apply a configuration through the API because Talos Linux exposes an HTTP REST layer and nothing else. And with this, you can then just apply a configuration to it. So you can tell every other node, okay, this is going to be your first coordinating node or the control plane node, and they all connect together with magic that the Talos Linux people did in Cedar Labs. And your cluster is basically up and running. And next time you want to upgrade, it's a few API calls, and then the cluster basically does a rolling restart of nodes, and you're done. And this way, you like eliminate one whole layer of infrastructure, which is the operating system management, and you ended up with basically a RESTful interface to control your Kubernetes cluster, which is super nice. And then on top of that, in the same Terraform run where we deploy this, we deploy Flux CD and Vault. Vault, HashiCorp Vault, you probably, some of you know it. It's like a, let's call it in this case, it's a secret store. It's much more, but in this case, we use it for storing secrets. It stores secrets encrypted at rest. And it's kind of like a center point in this because you don't need to deal with storing secrets with I don't know, sealed secrets in Git, and then you have to load GPG keys, etc. When you do disaster recovery, it's a bit more nicer to use. It also has like a user interface that your users can use later. I will show you. And then we deploy Flux CD, which is then directly connected to our Git repository where all of our application stack is. And then when Flux is up, it will just pick up the deployment files and deploy your applications. And your platform is done and ready to use. Most importantly, like what we didn't want to lose in this whole concept is also the security that the cloud providers give you. Like, for example, somewhere you don't even have this. Like, if you want to have your data encrypted at rest, you need to use full disk encryption, which is kind of hard to do on-premise. But luckily, Talos supports KMS, which is basically just like on the boot up, the system is asking a KMS server for keys to decrypt the disks, and then it can automatically do a reboot, so you don't have to type in the full disk encryption every time you reboot the nodes. And this is one big part of why it's reducing the maintenance overhead of the whole cluster. So we didn't want to lose this thing, which you can utilize in a cloud provider because they have all these nice things integrated. And also, we didn't want to lose this secret store management and usability, where your secrets are also encrypted at rest in a data store that cannot be breached easily. So this is why Vault, and this is why Talos, and this is why we opted to use KMS. I will show you, like, we built a couple of tools that we open sourced recently. One is to manage the Vault secrets, like export, import, and back them up automatically to S3 bucket, encrypted, of course. And the other tool is basically a KMS proxy. We just implemented the Cedar Labs, like the Talos Linux KMS interface, like so that the nodes can interact with this. And then in the background, you can use any kind of KMS you want. You can even use Vault. You can use AWS KMS, Azure, whatever. Our first implementation that we published is just using AWS KMS, but we will implement more backends for it. Good, so now you have the platform, but how do you now convert your developers to like dealing with some of these things? So we had a long discussion and the talk in the team, and we ended up having this kind of, I would not call it divide, but like unity. Like we started practicing actual DevOps workflow, not just DevOps as a team that starts doing infrastructure. We like doing DevOps in a sense, like we're working together on this. Like the operations team is providing this platform, the cluster, the foundations, all the infrastructure parts that the development team needs. But the development team then took over like the actual manifests of application deployments, scaling their application. If they need, I don't know, more memory in the system, they just can go and edit their YAML files and redeploy the applications without having to create a ticket for the ops team, wait for us to have the time to actually do it, la 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 la, and then wars start like this. So we ended up talking to every development team in the company, figured out the pain points, and this was kind of like how we split the workload. And then we also, like, quite crucially, like this was very important, there were people that just didn't know how to deal with this. Like they never used any of the infrastructure stuff, so how do you now get them to start using it? We started doing basically internal workshops with everybody that wanted. Like we had like a scheduled workshop each week, and whoever wanted to join was welcome. This was, of course, on company time. And this was a huge productivity boost. Like people actually were interested. Like we realized that development teams were actually interested in how they can speed up this. And they also wanted to understand like how everything works. So it was a very positive experience. And at the end of the day, it gave us the opportunity to free up the infrastructure team to do more innovation in infrastructure and to do more automation, to make things more stable, and to like iteratively improve this process of like what we provide and what the developers need and how we can build better tools and better stuff for them to make their job easier, basically. Good. So I also want to show you like a practical way of what this means. I have a cluster here that's built with this infrastructure for the sake of simplicity and speed. It's just running this pod info web app that is loading one secret from Vault, which is this message. Oh, damn. So I think I need to exit. Yeah, here we go. This is just for demonstration purposes. Like, one big point of this was like, okay, so we built this now, how stable is it? Like, if something goes off, like Hetzner Cloud goes down, the machines break, I don't know, something can happen. How do you do disaster recovery? Because you want to be able to survive an outage of some kind. And from ground up, like in this infrastructure that we built here, we tried to, like when we were building it, we were always testing, okay, just like remove everything, redeploy automatically. How long does it take? What did we miss? Like, did something not load? Why? Is there an interdependency loop between the components? So we built it basically to be able to run one Terraform command to deploy the infrastructure and the control plane layer. And then GitOps or Flux, in this case, picks up and deploys the applications. One thing that you have to do manually is basically restore the secrets in your vault. And of course, your database needs to be restored from the backup. We mostly use Postgres for our applications. So we just opted to using cloud-native Postgres controller operator, which is basically magic. Like you install the cluster, which is coded in YAML files. When your cluster boots up, you need to just switch it from uploading a backup to actually restore from backup. This is a one-time operation. Once this is done, you switch it back to backups and everything works magically. So there's two things. You restore your databases and you restore the secrets. Actually, the other way around. The secrets are necessary so you can connect to your backups, et cetera, et cetera. But like not losing the secrets and like not having to deal with manually decrypting now and uploading a key into the Kubernetes for like whatever kind of key store did you use before is nice for us because yeah, Vault is just a good tool for this. So we built another tool. Actually, I already mentioned it. Sorry. So we built this whole thing to be able to quickly recover. So this is something I want to demonstrate today. So this is basically the cluster. There's 6 nodes, 3 control planes, 3 worker nodes. There's mostly just infrastructure here. Basically, we're using local storage on these nodes, and we have Longhorn, which is basically a CSI for Kubernetes, which is emulating like a container storage interface, like network storage, but it's actually using local storage. And with this, you can also achieve like a very cheap storage solution, where if you have 3 or more nodes, you can just replicate your data on all of them. So if one goes down, your application just reloads on a different node, and everything's fine. So you achieve this like very cheap network storage safety in your cluster. So what I want to do now, like you see, we have this application, it's running, it loaded the secret here. The secret is in your Kubernetes, in your Vault cluster, and it's running fine. So what happens now if I just kill this cluster? We'll do just this, like these 2 scripts basically remove Terraform resources because we have to deploy Vault and Flux with Terraform because it's a chicken egg situation. And then we remove the VMs completely from the Hetzner cluster. This will take 7-ish minutes. So in the meantime, I will continue with the presentation, and then we will come back and see what happens afterwards. How we can just restore the cluster and load the secrets, and everything will be back again. So yeah, about the 2 tools that we built, like we built this KMS tool that's actually already explained it. However, like yeah, we open sourced it. It's doing 2 things. It's doing this KMS proxy, and because Talos is very security hardened distro, it expects like proper TLS communication on the other end. So we also built in the Let's Encrypt ACME certificate renewal support in it. So if you use this tool in combination with Talos, you start the tool, you give it credentials to your ACME account, and it will automatically basically create new certificates and renew them every X time as you configure it. Like there's parameters to do this. So it's very nice. Like, and we've been using this for 8-9 months now. It never had any issues. So yeah. Second tool is this Vault backup and restore tool. So what we did here is we wanted to make sure that the secrets are never exported or stored somewhere in clear text. So this tool basically connects to a Vault cluster, pulls the secrets from your secret store, and on the fly it's using age encryption. I don't know if you know what it is. Like it's basically like a crypto library that's very nice. That's using public key infrastructure to take your data, encrypt it with a private key, and store it encrypted on the disk. And then this tool has the ability also to upload this to a S3 bucket with an encrypted in an encrypted state, so it's safe there. Even if it leaks, like nobody can decrypt it. And then also there's a functionality like to pull the secrets and import them back into Vault cluster. So in case of disaster recovery, which we will see, basically it will enable us to, when the cluster is back up, we will just load the secrets, and then the applications will just recover after the secrets are there, which I will demonstrate there. This tool is also free and available on our GitHub page. I will post like there's like QR codes at the end of the presentation. In the meantime, like what's happening now, we're living through a cluster loss. Happened to us that somebody also like removed a production cluster by mistake. Luckily, it was an internal production cluster, but it was super easy to just restore everything with this concept and architecture. So you lose your cluster, you panic a bit. Next thing, you run your Terraform deployment, which deploys your cloud infrastructure, installs Talos. Talos boots up, and because we have this KMS proxy, like it will automatically, at first boot, encrypt the disks and store the keys in KMS. Then we install like the storage, we install Flux, we install Vault. Next thing you need to do, you restore your Vault with the Vault restoration tool. Flux will then pick up all the deployments. One thing you have to do is this database restore thing, but it's basically a simple switch in a YAML file. You push it back to Git. Flux receives this change. Cloud Native just basically picks up the backup, restores your cluster, and your application at some point just like retries to connect to the database with proper credentials, which you restore with your Vault restoration tool, and everything just starts working again. And that's it. Then you run some tests to see if everything's running fine. I hoped that this will work faster, but it didn't. One more thing like that's interesting in all of this is how we structured our Flux GitOps tool. Does anybody use Flux? Argo CD? Okay. Yeah, Argo is like a bit more popular tool because it has a nice UI. You can, create abstractions on top of it. We opted for Flux because it's using like bare bones customize underneath, and it has a concept of controllers. So there's like a source controller that's like connecting to a Git account. There's the customization controller, etc. So it's more modular and it's more slim. So for like smaller clusters and smaller teams, it's kind of easier to maintain. And one big thing that we liked for it is that like you can create different sources because of the source controller. Probably you can do something similar with Argo CD, but in this case, we structured our deployments in a way where we basically have our infrastructure Flux repository, where we have our monitoring, whatever, like external DNS, cert manager, all these tools inside. And this is only maintained by the platform team or the infrastructure team. And then each development team has their own repository, which can even be in their code Git repository, because with Flux you can just like check out like a subdirectory, which it will then read for customized files, and then through customize it will start deploying our applications. So what you can do in this case is like we call them like tenants. Like you can have a tenant for the apps team, you can have a tenant for your product team. And in each of these, basically, you define the namespace where this will be running, service accounts, role bindings. We actually use like OIDC connections to authenticate users to the clusters. So we even give developers access to the cluster, but only to their namespace. So they cannot break anything outside of it. And then you define your Git repository where it will read the manifest from, and you're basically good to go. You leave your development team to deal with their crap as they wish. You're not bothered at any time of the day. They're happy because they don't have to wait for you and explain to you, oh, I need another database instance, and you're like, why? And like, do whatever you want. Like, there's limits on how much infrastructure you can use, and everything's fine. Everybody's happy. In reality, in our company, we're not fighting like this. I'm just caricaturing. But basically, you see the point. Like, you like distribute this workload of deployments and overhead that the ops team had throughout the engineering department, which then leaves operations with more time to tinker with things like build these tools like KMS proxy, export import tool for Vault, or figure out this whole engineering thing. Okay, so now our cluster is down. See, this is dead, like not even Vault is in there. In Hetzner, there's no servers. We only have, like I didn't destroy everything because it takes a long time to deploy it. Like this management node is where we run the KMS proxy and our VPN server that connects us back basically to our company VPN, because we're not exposing these nodes externally on the internet. It's like they have a public IP, but like there's a firewall that prevents it. So we're just using private IPs to reach them. Good, so no, never use this flag. But I don't want to wait and tell it yes. So now we let it deploy the infrastructure again. So it will basically run for another 7 minutes. Come on, start. Okay, it's reading the previous state, and now you see the VMs come up. What you can also do, like if you have storage that's not a database, for example, I don't know, you're storing a bunch of files somewhere. Longhorn has a very nice backup and restore system also. So because you're using Longhorn and it will be deployed automatically, all you now have to do is go in and configure your backup endpoint, and it will just pull the data back. And depending on how much data you have, this is increasing your downtime, of course, but at least you don't need to worry about like which setting did I put here and there, like because this is all automatically deployed. There is no circular dependencies, like because you can make it like this, and you're not as scared anymore to like break everything, or you're not afraid if your cloud provider fucks up and you're now like dead in the water. You basically have this in code more or less. Yes, so while this is deploying, I will show you also, where is this connection? No, yeah. Also never use root user to connect to your servers. But this is a demo, so give me a break. Oh, come on. I'm sorry. I'm using a very weird terminal emulator that's not fully supported everywhere yet. So what's this log about? Or actually, let's just follow it. This is the KMS proxy, and as soon as these nodes now start booting up, maybe it already happened, you will see them basically decrypting their state, and then in here you see basically, okay, I'm sealing the disk for this because this is a new node, it's just starting, you first need to encrypt it with your private keys, and then after that it's unsealing this disk for this node, and then every restart it will just then be unsealing them when they reboot. And you can see this happening in real time. So yeah, it's a nice thing. So now you basically automated the boot up, and you have full disk encryption out of the box. You don't have to go to each server, type in passwords and whatnot. Care about this. Your data is safe. So yeah, good. So while we wait for this, let's talk about like what this means, like for you as an organization, like a smaller organization and team. What we did with this project, basically, we had like something like this. We had like a single project deployment in AWS where we had an EKS control plane, bunch of workers, an RDS instance, then some hidden costs that can be very huge, like egress traffic once killed us with costs. because you don't expect, like you don't know what the customer is going to do. The NAT gateways, the application load balancers, and like you want to connect to this through VPN, yeah, configure IPsec. I'm like, okay, but it's 2025. Like, let's not use IPsec. Anyway, you then use 80% capacity of this cluster, and it costs you around 1,000 per month. Like, this was our use case. The money thing is like not around 1,000, but like 1,000 and something. I just rounded up for demo's sake. But it is in this average. And this is one client, one application basically running up. So with the new infrastructure, we have basically, for a single project in this platform that I described, like we still use like a control plane. We use 3 nodes with the smallest type because it's just coordinating. Use 3 big workers in Hetzner. We use some management machines that's running a VPN, KMS proxy, etc. We have some private networks, a firewall, and some load balancers. And this is super cheap in Hetzner, and it's like this is static costs. Like you can know every month this is how much it costs, because Hetzner gives you 20 terabytes of traffic, like flat, like go nuts. And this is using, like for the same project, 20% capacity of this cluster. So you can have 5 of these projects in this cluster, basically. And it's costing us around 300 per month. So it's like a 70% cash reduction, but like also 5 times, because you can run 5 projects with this. So for us, this was huge. And one other big thing that basically we achieved with this is we reduced the toil from the operations team. We reduced the toil from the development team. Like they don't have to wait for us. I'm repeating myself, but it's like super nice to have this. Developers can work on their own. We are maintaining this, which is like we built in so much automation because now we have time. Like now we reduced our maintenance time from 70, like we were doing, I don't know, like 20% of building up new stuff and trying out new stuff. Now we're like, it's 70%. Like we have so much time on our hands because we automated the upgrades. It's another tool that we built in-house, like where we utilize the Talos Linux APIs, and we built like a Kubernetes controller operator that's constantly looking to the upstream Git releases. Hey, there's a new version, boom, download it, use the APIs to do a rolling release on the cluster, upgrade the Kubernetes, and it's done. And this is happening in the background. We're not even checking it at this point, like it's so stable. So this is gone, like you're not having to deal with like scaling databases, like increase my stateful set or whatever. This is gone from you. So we're basically maintaining this, making it more stable, scaling it if it's necessary. Like if you need more Hetzner VMs, this is something we need to do. But this is just like an integer in your Terraform script, and then it boots up, connects to your Talos cluster, and it's like shifting loads, and you're done, basically. And what we're now working on is like even automating this part, so auto-scaling, measuring the system load and integrating this into our Talos operator, where we can automate even this part. So yeah, before we end, like the key points, yeah, this is just Vault coming up, as you can see from the deployment. Is using OIDC to authenticate my Terraform client. So the infrastructure is coming back up. Vault should be here, not yet. The key takeaways from this is like, it's affordable by design, like you're not using fancy stuff from the cloud. It's automation-driven operations, so you achieved like basically reducing the maintenance time and increasing the innovation time and automation building time. And you empowered both of your teams, like now everybody has more fun, they're more productive, and things just work much better. And you achieve this with very low costs, a bit more upfront investment in building this up and setting this up, But down the road, I can just say that this is the way to go. I'm not saying like everybody can use this. Like if you're bigger scale, like maybe this won't fit for you. But I've seen so many clients that have like smaller infrastructure and they're like paying huge amounts for ECS deployments because that's the easiest thing to do. And like there's this where you can basically reduce your cost and improve your internal communication and internal workflows. So yeah, that's me. We can start with the questions. I will just, when this boots up, I will show you that it's for real. Yeah, okay, so deployed, but if you have some questions, I hope it was interesting. Like, I don't know how people see it, but yeah. So you see the cluster is back up. It's loading basically the infrastructure stuff. So this is basically creating certificates. External DNS is registering your DNS names for applications. Vault is up and running. We have 3 nodes. This is the Vault secrets operator that's basically reading the secrets from Vault into the Vault cluster and synchronizing them. So yeah, and the Flux operator is basically what's deploying your applications. That's it. Yes?
How long have you been using this setup for your company?
So as I said, like it's like productively 6 months. We started like testing this. I built the first concept in summer, and then we started testing it, and then slowly using it in more and more workloads.
Are you using vanilla Kubernetes from Google or?
No, so it's Talos. Yeah, so Talos is basically you pull an image, and when you boot this up, it boots into a Kubernetes.
Oh, right.
So it doesn't have, you cannot SSH to this, which might be scary at first, but like if you start going down this road of automation, you don't want to. Like I don't like right now. If I need to SSH to a machine, I'm like, damn, you know, because yeah, it's much more fun to automate things. So this is up, and basically this tool. Sorry, if there's more questions. Yeah.
How easy is it to switch to another cloud provider, or are you locked into that?
Not like the only lock-in you have is the infrastructure layer, basically this part here, but not even all of it, just like until here. You create your network and you boot up the virtual machines, and it just costs you to switch to this. And then in the next cloud provider, if you're using bare VMs, you boot the Talos, and the rest is in Terraform. Like it's not talking to the cloud provider anymore. It's talking to the API of Talos Linux. And then the Flux picks up and uses your manifests to deploy everything. So you're pretty much decoupled from cloud providers, which is a nice thing. Yes?
What do you think for which companies of which size would this platform be a good fit, and how many people would the platform team need to support the meetings?
So currently, for like in our company, there's 2 of us. We started out small because like the infrastructure already existed. And we maintain 6, 7 customers that for like our company is consulting them, also writing the application. So we're doing like the hosting for them also. So as I said, like we're touching these clusters much. Like they're upgrading themselves. Like we're just scaling them from time to time. I think that you can easily, depends on what you're hosting basically, but maintaining it, I think that's why small teams. I think 2, 3 people, depending on the size, is more than enough when you have the automation in place. So it reduces the costs, or like keeps the cost in this context. Like if you were a cloud shop and then you have 2, 3 admins that are maintaining this, like it's doable. Yes.
Since you're deploying your vault on the cluster, so you should unseal the secret manager first, and you have to authenticate. How do you handle this part?
So there's a couple of ways. The way we do it is basically, sorry, I just need to change the key because the Vault cluster is new. So the way we did it, we boot up the Vault cluster. Then we have an init script that's basically using KMS initialization of Vault. We use Azure because our identity management system is there, so it kind of fits into our role-based access control. And then you just point to Vault init script and say, okay, use this, use our Azure tenant to do the KMS initialization. So Vault itself is then encrypted through the KMS of whatever you want. And when it boots up every time, this is a functionality of Vault, basically. It's always calling the KMS system to decrypt itself. What you can do also, if you want to be independent of a cloud provider in this case, or if you want an offline platform, which is something we're aiming on or consulting some customers on, you can have another Vault instance that's like basically used as a KMS provider for your production Vault. So that one, I would not suggest be running in Kubernetes, just like it can be a virtual machine with a single instance or a cluster, however you want to build it. So of course, there's layers here, but for this production workload where your applications are running, this is like super, super nice. Yes?
The question, you're using GitLab, and then for the other stuff, for the CI/CD, you're using Flex CD. Is that what you were saying?
So GitLab is just our Git repository in this case. And Flux is then connected to your Git repository. The Git can be GitHub, it can be bare bones Git repository somewhere on the network that you can just then, you can use Flux, you can use different kinds of authentication mechanisms, like we're using SSH keys basically, which is then also not tying you to a Git provider like as GitLab or GitHub, whatever. So it's just an SSH key. So even if you switch Git providers, you just upload your same key and you're good to go. And Flux is then, there's two ways, like it can either pull periodically, or you can implement a webhook if you're using GitHub or GitLab to like do post-commit hooks, and then it just notifies Flux right away, and it's kind of faster.
And your developer team has to use like everything in code files, and it's not like you have a UI for it, or so it's just a...
For Flux? So we have like just UI so that people can take a look at it, but mostly we kind of use K9S because even developers like it so much because it's super, super nice to. So I don't know. But there's a bunch of user interfaces for Flux. We just have one for the sake of it, like the ops team uses CLI. And yeah, the users don't really interact much with it. They just, like we created also templates for application deployments. So based on the project or like what kind of app, if it's a Java app, we kind of have like a basic template, and then they can expand on this in the manifest. Yeah, so this, as you can see, started working when we loaded the secret, and this is just because I'm using staging for Let's Encrypt. I don't want to spam them. And you can see this is the secret in Vault that it's loading through an environment variable. It's just a small demo of how you would do disaster recovery. Okay. Yes.
So, what kind of service you for paying on HeadsNet? So is it like VDS, something like that?
It's just virtual machines.
Okay, and also second question, you said that you buying some, I don't know, virtual machine, and
well, you're paying like 300, and it's enough for for 5 customers. So you bought more than you needed. So is it because it's not flexible enough, or it's just?
Well, it was kind of like we went through it and tried to figure out what we need. Like, this is the bare minimum of number of machines that I would use in production. Like, you need 3 coordinating nodes to build a quorum. And I would never host production application that doesn't have 3 instances running also. Like, depending like what you do. Like, mostly we have Postgres running, and we have, for each database, we have 3 instances. Also needs to build a quorum, so you need 3. And then we just calculated the cost, so we bought the most expensive virtual machines, and it's more cost effective than having like multiple clusters with smaller VMs. So this is kind of our like base cost, and we didn't like want to have overhead, but now we just put multiple customers on this. If we are allowed to, like some customers want their own cluster, so like whatever, here you go, we charge them the costs. But they're still happier than paying the AWS bill. So yeah. Yes?
What's your thought on having a database on your own versus a managed instance?
We're using our own databases. Like with, as I said, like with cloud native Postgres, it's just pure magic. Like I've never seen a better operator in my life. It just works, and it survives. Like we had different kinds of outages for different reasons, it just survives. So I don't think at this day and age, for like depending on your size and scalability requirements, I don't see why you would need a cloud RDS instance with this kind of tooling nowadays. We're super confident with it. Yes.
How do you handle the storage for the database?
So we use Longhorn CSI. So each VM has local storage. And on Hetzner, like most of these machines have like 300 gigabytes, 400. And then Longhorn comes on top of that and utilizes this local storage. So what we also do, we increase the replica of each volume. So every time you create the volume, Longhorn replicates it at least twice. So on these 3 nodes, you have data replicated. So if one goes out, like you...
I don't know, but the storage is on the virtual machine. Is it ephemeral or does it?
No, it survives a reboot.
Okay.
Like in Talos, you have an option. Like if you reboot it, it can just remove everything, or you can tell it, okay, keep the state of this state partition where the data is. Okay. So it's a configuration thing you can do. You can also basically buy like a Hetzner storage box and just connect it via SCSI or not SCSI, NFS or whatever you want. Yeah.
Have you ever worked with the scalable protocol? Since I have this issue exactly with implementing use the scalable, but due to the multi-path, we encountered this plugin.
I used it 10 years ago when Kubernetes was not a thing in an on-prem setup. We were having huge Elasticsearch installations, so we needed a lot of storage. But
Don't get me wrong, I'm not talking about the whole thing. In Talos, you need to add the extension, the scalable and...
you can add them, yeah.
Yes.
But I don't have experience with it. We don't. Sorry, like I wouldn't have experience with that. What we did use, like we combined virtual machines and like external servers that have storage then, so you don't have to, like you abstract it through a different way. Okay. Yes.
You don't happen to have a guide for replicating the setup ourselves?
So like this presentation, I think it's somewhere online. I can put it online. I was thinking of actually putting this also in our Git repository. Ours is kind of tightly coupled to our workflow. So yes, it's something that I want to do. It's just the time that I need to invest to it. And when my boss says, okay, go for it. It's not like if you have experience with these things, like it's not that super complex. The biggest challenge was like, how do you do chicken egg? Like when do you deploy Vault? When do you deploy Flux? Because like, which comes first? So there's a bit of Bash script magic in there in Terraform, exec modules, etc. But it's not really that magical. I want to put it online, but like I didn't have time to like do a clean version. And then like, what my wish would be like for us to create like Terraform modules that you can just then import and use for these things. Like we have internal modules, but they're not like properly packaged yet. Yeah. Yes. That was our first thought on doing that. We just like, why? But yeah, but of all of these products, like I have a lot of experience with Vault, like from even before, and it's just an amazing tool. Like we want to start using it for more things, like doing dynamic secrets in Postgres, in applications, etc., etc. Like it has super nice security features and encryption primitives that you can utilize in your application. So for us, sorry? No, no. They just switched the license from MIT or from Mozilla public license to business source license, which doesn't touch us because we're not reselling Vault as a service. It's just an internal component. No, Vault is free, and you have like a Helm chart to deploy it from HashiCorp, or dare I say IBM at this point. Sorry? No. We deploy Vault in the Kubernetes cluster. So each cluster has its own Vault. We also thought about like having central Vault for all the clusters, but it's a design choice. Yeah. So we're out of time, sorry. But if you have questions, I'm here for a while. Thank you.